And then there is sum and difference identity. This is the formula for sine A plus B equal to sine A cos B plus cos A sine B. If it is plus, this is also plus. Sine A minus B is sine A cosine B minus cosine A sine B. So if it is negative, this is also negative. And then the formula for cosine A plus B equal to cosine A cosine B minus sine A sine B. If it is positive, this is negative. And also cosine A minus B equal to cosine A cosine B plus sine A sine B. If it is negative, this is positive. And also tan A plus B equal to tan A plus tan B per 1 minus tan A tan B. And then tan A minus B equal to tan A minus tan B per 1 plus tan A tan B. Okay, let's jump to the example. Cosine 75 is equal to cosine 30 plus 45. We know that the formula of cosine A plus B equal to cosine A cosine B minus sine A sine B. Let's assume the A equal to 30 degree and the B equal to 45 degree. So cosine 75 equal to cosine 30 cosine 45 minus sine 30 sine 45. We know each and every value of this. So cosine 30 equal to a half of square of third. Cosine 45 is a half of square of 2 minus sine 30 is a half multiple with sine 45, a half of square of 2. So we got that cosine 75 equal to a quarter of square of 6 minus a quarter of square of 2, or a quarter of square of 6 minus square of 2. That's the value of cosine 75. Okay, let's jump to the exercise 9b number 5. Prove the following identities. Sine A plus B minus sine A minus B equal to 2 cosine A sine B. Okay, we can expand this and expand this one. We work from the left to the right. So sine A plus B equal to sine A cosine B plus cosine A sine B. And then sine A minus B equal to sine A cosine B minus cosine A sine B. And then sine A cosine B plus cosine A sine B minus sine A cosine B, you multiply the minus times minus equal to positive. So plus cosine A sine B. This can be dismissed because this is basically the same. So we got that cosine A sine B from here plus cosine A sine B from here. Okay, so you can add all this together, it becomes 2 cosine A sine B. So it is proved. And then the double angle identities. We know that sine A plus sine B, this is the formula. How about we change B with A? So sine A plus A equal to sine A cosine A plus cosine A sine A. So sine 2B equal to 2 sine A cosine A. And we also knew that cosine A plus B, this is the formula. We change B with also A. So cosine A plus A is cosine A cosine A minus sine A sine A. So cosine 2A equal to cosine square A minus sine square A. We can exchange cosine square A with 1 minus sine square A from the previous identity minus sine square A. So cosine 2A equal to 1 minus 2 sine square A. And also we can exchange sine square A with 1 minus cosine square A. So cosine 2A equal to 2 cosine square A minus 1. We have two formula for the double angle for cosine. Cosine 2A equal to 1 minus 2 sine square A, or 2 cosine A or 2 cosine square A minus 1. And then for tan A plus B, this is the formula for tan A plus A equal to tan A plus tan A per 1 minus tan A tan A, which means tan A, which which means tan 2a equal to 2 tan a per 1 minus tan square a. Let's jump to the example. Prove that sine 3 theta equal to 3 sine theta minus 4 sine cube theta. I'm going to work from the left to form the right. Okay, sine 3 theta equal to sine theta plus 2 theta. This is the angle of sine. So sine theta plus 2 theta equal to sine theta cosine 2 theta plus cosine theta sine 2 theta, the formula of sine A plus B. And then we can expand this with 1 minus sine square theta, cosine 2 theta double, cosine double. So sine theta multiple with 1 minus 2 sine square theta plus cosine theta multiple with sine 2 theta double angle. So sine 2 theta equal to 2 sine theta cosine theta. We just simply multiple sine with this one and cosine with this one. So you will get sine theta minus 2 sine cube theta plus 2 sine theta cosine square theta. Cosine multiple with this one. So it is cosine square. Now we can exchange the value of cosine square theta with 1 minus sine square theta. So sine theta minus 2 sine cube theta plus 2 sine theta multiple with 1 minus sine square theta. You just have to multiply this one to this one. So sine theta minus 2 sine cube theta equal to 2 sine theta multiple with 1 equal to 2 sine theta. 2 sine theta multiple with minus sine square theta equal to 2 sine cube theta. So sine theta plus 2 sine theta equal to 3 sine theta, and negative 2 sine cube theta minus 2 sine cube theta equal to 4 sine cube theta. So it is proved.